Hello, good evening, and if you're watching this, then you are either live, which is unlikely because I only gave 5 minutes warning to my class. You're one of my class who are preparing for their unit test on Thursday, so good luck with that. Or you found it via a search engine any time between now and many, many years into the future, and maybe you're using it for some sort of history study in 200 years ago. What were people like in those days, back when they only had 2 arms and 2 legs? So yeah, this is what we like weird, crazy people who just we want to learn about maths. But if you're here because you're searching for density and the compound measures and percentage change and all the multiplication chapter, Unit 11 of the EdExcel higher tier GCSE, then you're in the right place, and hopefully I can make things make sense to you. So what I'm going to do is I'm going to go straight into the intro, and then on the other side of the intro we will go straight into starting doing the questions. Now in the description below you will find a link to questions. I strongly recommend, unless you're doing this live, download those, attempt the questions first, then watch the video, pausing at different points, making corrections, fixing your learning, then put the video away, put your first effort away, and have a second effort at the questions, and hopefully you'll be able to get 30 out of 30. If not, then go again until you fully understand what's going on. And obviously you can always email me at the places down the bottom, contact me and ask me any specific questions, or comment in the video below the video, and I'll happily try and help you. So, let's get started. Oh, I'm back. I'm looking over there trying to work out what's going on, and so I'll go straight into the screen here where I can start to do my questions. Now I've worked them all out. I've got a question per screen. I will try and write them. I'll hopefully not have a face in front of any questions. If that does happen, I will notice about 10-15 seconds later, and I'll be able to just adjust it. But it might take a few seconds of sort of just checking things out, and I might have to slide things around a bit. But I'll try and do my best. Now, what we've got is, first question is change the speed of 32 kilometers per hour into meters per second. So first thing we're going to do is I will turn that into 32,000 meters per hour. That was just simply by multiplying by 1,000. The next thing I need to do is more complicated. I'm going to divide by 60 and divide by 60 again, because I need to turn hours into minutes and minutes into seconds. So because it's this many meters per hour, we're going to have less of them. That's why I'm dividing, because there's going to be less of them every minute, and there's going to be less of them every second. So let's divide it by 60, and I get, my calculator delivers 1,600 over 3. I could write the decimal, but because we're going to do more things, I'm going to go straight to 8.8 recurring meters per second. I will accept 8.9 because you can round it. Meters per second is also true. If you don't want to use 8.888, you can go 8.9. Both of those answers are acceptable. And you'll notice there's 3 marks available for that, so it'll be 1, 2, 3. Always useful to look at mark analysis to see how complicated it is. Although in this question, the second one, it's really simple. It's a case of 42 is going to be divided by 7, because we want to put the 42 in there. We want to put the 7 in there. It's just 42 over 7 for 1 tick is equal to 6 newtons per metre squared in the second. Now I'm just going to bring up the other screen just in case I've got anyone who is joining us live. It's unlikely. We might have a couple of live people join us at various different times. Okay, so the next question is, I'm going to move on to the next bit, and for some reason it doesn't like it. That's what direction I wanted to travel. If you do join live and you want to say hello or anything, do feel free to. That's absolutely fine in the chat, and obviously I'll try and respond and answer any questions if anyone has any. So the next set of questions is the 3 and 4. Now the first thing I would do, because I know this triangle is the density, mass and volume triangle. Density is going to be dmv. I want to know the mass, which means I'm going to need to do d times v. So I need the volume. And the volume here is going to be 5 times 2 times 8. So the volume equals 80 centimetres cubed. And the density it gives us is 1.2. and we're told to multiply them, so it's 80 times 1.2, so we're going to get an answer here of 96 grams. If you don't put units, you lose out. There are 3 marks here. I would say the calculation, the answer, and the units. Units are important. Please make sure you are aware of that. Now in number 4, we've got A is directly proportional to C. Now I'm going to go through this exactly how I did it in class, with my class. Obviously, if you're not in my class at school, try and follow along, and if you want to ask me any questions, do so in the links in the description below there, just in the chat. Feel free to ask me any questions. But the way I do it is, first of all, it says A is directly proportional to C, so I write that down. That means it's proportional to. Then I immediately say, in that case, A equals K times C. K is just a number, a letter that I'm using as a placeholder until I've got a number. So the next thing I'm going to do is say that A is equal to... I'm going to swap in what A is, sorry. I know that A is 27 here, so 27 equals K times 8. So I divide by 8, and K equals 27 over 8. So I've got... I put the numbers in the wrong way around, haven't I? I wanted to put... A is directly proportional to C, so I want to put A to C and C to A. Anyway, that's fine. I've got it the right way around. K is 27 over 8. The reason I'm throwing myself is when I was working it on paper to try and make sure I gave it all right, I worked this the other way, but it won't affect the answers. Okay, so it then says find the value of A when C is 11. Because what I can do is immediately rewrite this as A equals 27 over 8 times C. So what I'm now going to do is I'm going to say when C is 11, A equals 27 over 8 times 11. And I'm going to immediately put that into my calculator. 27 over 8 times 11 is going to be 37.125. 37.125. And just to demonstrate that it does work out, I actually had these the other way around, but it still gives me the same value. So it doesn't matter if you accidentally have C is proportional to A or A is proportional to C in this context. The second part, so we've just done part A. Part B, we need now C. A is 108, so we've got the sort of the answer, if you want. I don't like thinking of it like that, but we've got this now. Now, when you're doing a thing like this, I've got to get rid of this bit, and to undo timesing, we divide. So C must equal 108 divided by 27 over 8. Now, if we weren't using a calculator, all of these questions you're allowed to calculate, so it's actually a moot point. But 108 divided by 27 over 8, if you didn't have a calculator, you could just flip the fraction and turn it into a times. But it gives you 32. That is your overall. And it's got no units, so we're happy with the 32, and we're happy with the 37.125. So it's just making sure you're clear on those. Anyone who's wanting a good time to pause, feel free to pause now if you're just going through some answers and wanting to leave that on the screen. But I'm now going to move on to the next question. Question 5 and 6. So a motorbike costs £6,500. I always want us to draw attention to the key bits. It decreases in value 23% per year, and this is the calculation Pippa did. Now we have to, first of all, to check whether she's right or not, we have to think about what is going on. Now, I hope that most students would look at this and go, she cannot be right. There is no way, if she's decreasing that much a year, that just to clarify here, that's £3.3 billion over 3 years. We should realise straight away that there must be a mistake and try and work out what it is. Now, it should be amount times percentage change to the power of years. But if we look at what Pippa has done here, this is amount times percentage change. She started off fine. But she has then times all of that by the power 3. And that is where she's gone wrong. And you have to explain it, because it says you must explain your answer. You have to explain your answer. There's only 1 mark available. You get nothing if you don't explain fully. She has not used the correct formula, because it is amount times percentage change. It is only the percentage change that gets multiplied by the number, that gets raised to the power of 3, not the whole calculation. Okay, We are now looking at question 6. Question 6 is a car depreciates in value by 30% per year. So the first thing I'm going to do is think depreciates means to go down. So we're going to go down from 100 by 30, we get 70%. I'm immediately going to write that as 0.70, but we don't need the 0. So it's just 0.7. 0.70 won't ruin the question. That's why I've put it in there and showed you. You won't get it wrong, but I'm just showing you really mature, sensible students would no longer put the 0 on the end. Then, to find part B, that was part A, very quick. To find part B, we raise that 0.7 to the power of 4, but it says give your answer as a decimal, not as a power. So the decimal it gives me is 0.2401. Again, if you have any questions, put them in the links below, in the text below, and I'll happily respond to them. Or email me. Here's a bit of a pause for you to break, so you can pause if you want to. Number 7 and 8. Number 7 and 8, I have a specific method I do this. It's inverse proportion here. It takes 3 cleaners 8 hours to thoroughly clean a house. When I see something like that, I immediately go, in which case 3 times 8 is a total of 24 hours work. Hopefully that makes sense. We've got 3 cleaners doing 8 hours each. That is a total of 24 hours of work. Now we know our total hours of work. 4 cleaners would be 24 divided by 4 is 6 hours each. Because we've got a total of 24 hours work to do, and we've now got 4 people to share it amongst. However, this only works if we assume that all cleaners work at the same speed. Now this is the sort of thing that in maths we can say things like this and say, this is true, like obviously all cleaners work at the same speed, but in real life we obviously have to understand that's not going to be the case. We can use an average, but we understand that everyone does things at slightly different speeds. But when you're doing mathematical questions, you make assumptions like this, but you must state what the assumptions are. All cleaners work at the same speed, so therefore this question works. Now, Freddie's been on holiday back when we were allowed to go on holiday, and the sailing time was 5 hours 12 minutes. Now the problem is, when we're doing our speed distance time, S, T and D, we want to know the distance, so we would need to do speed times time. However, we have got kilometers per hour, and this is not an hour. And you must not, it is not equal to 5.12. Because hours are not out of 100, they're out of 60, it is not a decimal. So the first thing I do in my calculator is 12 over 60 is 0.2. Therefore, this is 5.2 hours. And it's a big thing to get your head round. But as soon as if you make sure you understand this for the rest of your life, you understand that 5 hours 12 is not a decimal time. To make it a decimal time, you take the minutes bit, divide by 60, and then you have the hours and the hours in a decimal. Now I can do 5.2 times by 70, and it gives me the value of 364 kilometres I've travelled. Again, if you want full marks, that units has to be there. We were told it was kilometres per hour. We were told it was hours because we turned it into a decimal number. Now, just a clarification here. Remember, it is not equal to 5.12, so it was necessary for us to do 12 over 60 to get a decimal bit, and that gave us 5.2 hours. Then we were able to multiply them together. Okay. Now that moves us on. So I'll give you a pause window and move on. Question 9. We're getting close to the end now, so we've got 3 questions to go. And that means it's time to turn my page over. And it is 4,000. I was a bit in the way of that last video, and I didn't even notice. So apologies, there's a little bit in front of me with my thing in front. But the main thing I've written, I said verbally as well, so you should still understand it. So the next bit. £4,000 is invested for 5 years. So we've got amount times... now, we want to do a compound interest. So it's 100% plus 1.5% gives me 101.5% or 1.015. So this is going to be 1.015 to the power of 5, and then you then immediately do that calculation and you get 4309.14 rounded to the nearest pence. I know there's more decimals, but I'm going to round it. So when you round it, you make sure it's the nearest number of pence. Now the thing is, some people will not notice, it doesn't say how much I got, it says just work out the interest. And lots of people will not get the full marks here because they'll do this calculation and they'll be like, oh, I'm brilliant, I'm wonderful, me. And they won't go, but it only asked about interest. So now we must take away our original amount and just write down that it's £309 is the interest because we started with 4,000, so we have to take that away. So if you don't do that bit, you will throw marks away. It is the amount times by the percentage to the power of years, but we then take away the original amount if we're trying to work out just what the interest is. Pause window. Finally, like these two questions, I'm just going to check on the video that these are above the height of my head. So if it covers that bit, I'll move it over slightly. Now we have got two values of x and y. Now this is a trick that I hope people spot, and it's not so much a trick, but it shows the understanding of the question. On this, what we do is we compare the growth. For 3/5, the scale factor here is 5/3, and it compares to here. If we divide that number by that number, we must also divide that number by that number, and it compares to 54, but that simplifies on our calculators to 125/27. Now, if you know your square and cube numbers, you will spot that that equals 5 cubed over 3 cubed. So compare that to what we had. The scale factor of 5/3 becomes 5 cubed to 3 cubed. That tells us that the relationship between x and y is that y is proportional to x cubed, because when the x is times by 5/3, the y is times by 5 cubed over 3 cubed. It's something you have to learn. If that number had been, for example, 25/9, it would be squared, but it's not, it's cubed. So we're looking for the comparative numbers. How has x changed? How has y changed? How can we use that to work out which one of the statements is correct? Finally, number 11. We have got Isha investing £6,000, and all of a sudden, there it is, £6,000 at a rate of 1.023 per annum per year. That is what that means. And it says, after how long will that be worth 6,500? So what we do, and this is a trick I would very much recommend, write down 600 in your calculator and then write equals. So all I've done is set the number 6,000 in my calculator. I am then going to write answer times 1.023 and press equals. That tells me that after 1 year it is 6138. You don't have to write these down, but what I'm going to then do is keep pressing it until I'm going to get beyond 6,500. So I will write down each time. The next one is 6279 ... Yeah, I could round it, but I'm not going to. I'm just going to leave it as the whole numbers because I only want to go beyond 6,500. Press it again. I've got, type it again. Again, all I had to do is press equals. I didn't even have to write this bit. That is what the calculator is doing, but I can just press equals each time. If I just keep pressing equals, it does that calculation for me again. 6423.59, but that's 3 years. And if we press it one more time, it's going to be 6,571, and we now can write the exact amount, 34, and you'll notice it's 4 years, and the question says, after how many years? So we write our final answer as 4 years. If you haven't shown this working, how will anyone know how you worked it out? So it's important that you write down the responses, but it's just a case of copying numbers out from your calculator. What I'm doing is setting 6,000 in there, multiplying it by 1.023, and then keep pressing equals, 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 and on the fourth time I press equals, that's the fourth year, it finally goes above the number we're wanting to check. So that's how we know it's 4 years. And that is the end of the worksheet. What I strongly recommend you do now, having corrected everything and gone through with me how to do it, is now turn the video off, print it out a fresh sheet, or just start a clean bit of paper and put all your working away, and see if you can now get all the marks ready. And if you can, especially if you're in my class and you've got the test on Thursday, you'll be able to work straight through it and sail through it. But even if you're preparing it in a year's time, someone else is in year 10 preparing for assessments, or just trying to learn a bit more about it, revising for GCSEs, it's all good practice. Like I say, at any time, it doesn't have to be in my classes, it doesn't have to be pupils I teach. At any time, anyone watching these videos can message me on the emails. So just got to bring them up again. They can message me on any of these forums, or just in the description, in the chat below the video, and ask me questions about maths, anything I've talked about, or anything else. I'll happily help. I'm happy to do team calls, Zoom calls, whatever that is useful in this weird time that we're currently living in, where people are zooming around and everything because they're stuck at home. So hopefully that's been useful. I've been Mr. Harris. You haven't. Thank you very much for joining me, and take care.